Good morning, class. I guess you get to stay home and do schoolwork today, so I'm going to go through what I was going to go through in class. I guess first I want to remind us where we are. Here's our standard that we're working towards, and today we're down here at the bottom. Multiply a monomial by a polynomial using the distributive property. And once we're done with that, so we've already done the two above there. And once we're done with that, we're going to go up here and learn how to multiply polynomials, and we will be done with this section. When you multiply a polynomial by a monomial, so here's our monomial out here, a single term, and it's being multiplied by all three terms here. So basically this is the distributive property. So we're going to multiply the 6 by each of the numbers inside. So 6 times 4 is 24. And then we multiply the y's together, or the variable parts. Y times y squared is y cubed. Remember the exponents, just counting how many y's are being multiplied together. And since we had 1 out here and 2 in here, that's how we end up with 3. We add the exponents. The next term is negative because of that minus right there. So we have minus 6 times 9, there we go. 6 times 9 is 54. And again, y times y, y squared. So the exponent there is telling us there's two y's multiplied together. And then the last term is also negative, so minus 6 times 7 is 42. And y doesn't have anything to multiply by, so it's just 42y. And I'm going to move this all down. Waste over. Okay, so there, and because, now, one thing to stop and think about is, am I done? Well, all of these terms have different variables, y cubed, y squared, y, so they can't be added together. So we are done. And, yeah, that's it. The next problem, example, is similar. We have a 3 that's being multiplied by this whole polynomial. Again, this 3 is being multiplied by everything in that set of parentheses. And then this 6n is being multiplied by this polynomial, which is actually just a binomial. So the first one, only the number gets multiplied. 3 times 2 is 6. And since there's no n outside or any other variable, the n squared just stays n squared. 3 times 4 is 12, but that's a minus there, so minus 12n. And 3 times 15 is minus 45. Again, the minus comes from the sign here, and because we're multiplying by positive 3 out here. Okay, then the next term is plus 6 times 5 is 30, and then n times n is n squared, and 6 times 2 is 12, and that one just has a single n from the 6n. Now we do have something we can add together. We have some n's, and we have some n squared. So 6 plus 30 on the n squared part is 36 n squared. Remember, we just add the coefficients. These are just telling us what we're adding together, and since we added n squared and n squared, we get more n squared. We have a negative 12n here and a positive 12n there, so that's up to 0n. I don't have to write anything. And then minus 45. And again, are we done? Yes, because we have an n squared and we have a constant term, but those don't have the same variable, so they can't be added together. So that's the basic concept of multiplying a monomial times a polynomial. This next example is a word problem, but it's still basically a monomial times a or it's still multiplying. This person, Kachima, is making triangular bandages for the dogs in her dog owners club. The base of the bandana is the length of the collar. We don't know how long that is, but we have, some length here, with 4 inches added to each end. So we had 4 inches over here and another 4 inches over here. So altogether that thing is x plus 8 inches long, right? And the height is 1/2 of the collar length. So it's a triangle and the height is 1/2 of the collar length. Well, remember the collar length was this original x before we added, so it's just a 1/2 x. And it says, write an expression. So we're not going to have a number answer or an equation or anything, just an expression for the area of the bandana. Well, area for a triangle is 1/2 the length of the base times the height, which in this case is 1/2 times the base, which is x plus 8, times the height, which is 1/2 x. I'm going to go ahead and multiply these two together first, so it makes it a little bit simpler. Actually, I'm going to move the whole thing over and give myself a little bit more room. So 1/2 times 1/2 is 1/4. When you multiply, you just multiply the tops together, multiply the bottoms together. The x is still there, and then we times that by x plus 8. And just like above, we multiply the 1/4 times the coefficient, but the coefficient here is a 1, so that's 1/4. X times x, x squared. Multiplying these two things. And then the next one, we multiply 1/4 times 8. That'd be 8/4, which is 2x. So there's our expression for the area. I guess we can write an A out in front there. Write an expression for the area. 1/2 base times height, multiplied together gives us that. If a dog has a collar, remember x is the collar length in our example over here, our model. If a dog has a collar length of 12 inches, how much fabric does she need for this dog's bandana? Well, we're just going to use our formula, 1/4 x, we're going to put a 12 there, plus 2 times x. Well, this is 144, divided by 4 is 36, I think it's 12. 1/4 times 144 plus 2 times 12 is 24. I think this is 36 plus 24 is 50 plus 10 is 60 square inches. So, because we already had a formula, all we had to do is plug in the 12 and we get the area. And the second problem is just like it. If she makes a bandana for her friend's dog with a 6-inch collar, we're going to do the same exact formula, except we're going to put 6 there. Now, you might think, oh, it's just going to come out half as big, but I think we'll be surprised. 6 squared is 36, so it's 1/4 times 36 plus 12. This is 9. 9 plus 12, whoops. 9 plus 12 is 21 square inches. Well, why isn't it half? Well, because this number got squared, so when we cut it in half, we ended up with 1/4 as much, because 1/2 squared, yeah, 1/4 as much from that part. We did end up with half here. The 24 became a 12, but the 36 became a 9, so it doesn't work out just like we would expect. But those two are just arithmetic. This was the one that had to do with multiplying polynomials. In this case, it was a monomial. Well, we could make it a monomial times a binomial, x plus 8. Okay, last example. We have this trapezoid here. She's covering a trapezoid-shaped poster board with gold paper to look like a bar of gold. The height of the poster board is 18 inches, so we can put that in. 18 inches. How much? Okay, so first of all, I'm going to write an expression. I guess how much we're talking? Yeah. I'm going to write an expression for area of a trapezoid. It's 1/2 the two bases added together times the height. So for this problem, the two bases added together are these two things. So it's 1/2 times 2h plus 4 plus h plus 1. Now, I could put those in parentheses like this, but it's all adding, so it really doesn't matter, times the height of 18. So 2h plus h is 3h, and 4 plus 1 is 5, The 1/2 times the 18 is 9. But we keep doing h here, but we know h. h is 18, so we can plug that in. 9 times 3 times 18 plus 5. Oh, not so many parentheses. Let's see. 3 times 18 is 30, 54, 59. Which is 177? No. 9 times 50 is 450 plus 81, 531. Let me just check that really quickly. Yeah, 531. Okay, so there's some examples for you. You've already done some ALEKS problems involving multiplying monomials times polynomials, so hopefully you'll be able to do these as well. So there's the book assignment, 501, numbers 18 to 28 even, 38, 40, and 42. And have a good day, stay warm, and like and subscribe.